Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Honors Geometry class. All right, guys, we're going to continue with quadrilaterals today, and we're going to prove today when a quadrilateral is a parallelogram. Remember what we had talked about? Parallelograms are kind of the key figures for quadrilaterals. It's kind of what we base most quadrilaterals off of. So it's very important to recognize when a quadrilateral is a parallelogram. Because once it's a parallelogram, then that can activate several other kind of quadrilaterals. So let's talk about it. A quadrilateral is a parallelogram, number one, if both pairs of opposite sides of a quadrilateral are parallel. Then the quadrilateral is a parallelogram. So if both pairs of opposite sides of a quadrilateral are parallel, then the quadrilateral is a parallelogram. And of course, you can reverse the definition. So what happens here is, pure definition, if I have opposite sides are parallel, no, you don't say it's a square. No, you don't say it's a rectangle. No, it's a parallelogram. Now, if both pairs of opposite sides are parallel, and then now you start throwing in 90-degree angles, you start saying that the diagonals are congruent, okay, now you can start saying, oh, that could be a rectangle now, or it could be a square now, or et cetera, et cetera, et cetera. But if I just give you a figure like this right here, and I show you a four-sided figure, or in other words, a quadrilateral, hello, we're in geometry, and the opposite sides are parallel, it is a parallelogram, period. Could it be a square? Yeah, could be. Could it be a rhombus? Maybe. Could it be a rectangle? Maybe. But for sure, it is a parallelogram. That is the pure definition of it, guys. I just don't want you to make that mistake later on. I don't want you to see a quadrilateral, opposite sides are parallel, and you say, oh, okay, it's a square. No, not by definition. By definition, it's a parallelogram. Correct, my brother. It has to fit all the other requirements of a rectangle to become a rectangle. Thank you, my brother. Because remember what we learned yesterday. A rectangle is a parallelogram where the diagonals are congruent and all of the angles are 90 degrees. Once those extra two requirements or conditions are met, then it becomes a rectangle. Good connection there. And that's what I need you guys to see. Right here, all I have is a parallelogram. Does that make sense, guys? Okay. Number two, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. It's converse of the property. In this particular case, again, you may say, Mr. Morrow, that's a rectangle. No, it's not. No, it is not by definition. That is a parallelogram. By definition, if opposite sides are congruent, that is still just a parallelogram. Now, could we add extra things to make that a rectangle? Sure. But right now, straight up, if opposite sides of a quadrilateral are congruent, then it is a parallelogram. That's it. Okay? Make sense? Number three, if one pair of opposite sides of a quadrilateral are both parallel and congruent, then the quadrilateral is a parallelogram. So if I have just one pair of opposite sides that is parallel and congruent, that's a parallelogram. Again, trust me, I know the frustration here, guys. Mr. Morrow, please, sir. A rectangle has opposite sides that are congruent and parallel as well, Mr. Morrow. Why are you doing this to us? You're right. But by pure definition, if I gave you that figure right there on number 3 on the test or a quiz, that's a parallelogram. Now, if I were to add this to it, now we can say rectangle. or square. Depends on what else I give you. But straight up, if opposite sides are parallel, that was number one, parallelogram. Opposite sides are congruent, parallelogram. One pair of opposite sides are parallel and congruent, parallelogram. You with me here, guys? Thank you, gentlemen. Number four, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So if I see here a quadrilateral, oh, that was ugly. Let's try to do that a little bit better, huh? That's a little bit better. And they bisect each other. It's a parallelogram. Yeah, but Moro, rectangles do the same thing. Yeah, but rectangle diagonals are also congruent. So that is not enough to determine that it's a rectangle. If you see a figure just like that, you see a quadrilateral, you see two diagonals, you see that those diagonals have been bisected, that purely proves solely that it is a parallelogram. Only. Are you guys seeing the difference here of why this can only be a parallelogram? It's a very important section. And number five, last but not least. Sorry, yes, sir. Sorry, my man. If there's no tick marks, then I can't really prove that it was being bisected, sir. Then I can't prove that. Maybe I have a letter here. Maybe I have a point. And then maybe I tell you DE is congruent to EB and AE is congruent to EC. Maybe I could explain it that way. But if I just gave you a quadrilateral, for example, let's just say I did this. Let's just say I did this. I give you this quadrilateral, and then I just do that, and I have no other tick marks. All I can say is, okay, it's a quadrilateral. I can't say anything here because I don't know if opposite sides are parallel or congruent, and I don't know anything about these diagonals. I know that there are two diagonals. Awesome. I mean, no sarcasm, but woohoo, good for me. So what? I don't know if they're congruent, and I don't know if they bisected each other. Now, once I know that they bisected each other like here, now I know for sure it's a parallelogram. Can it be something more? Sure. What other clues am I given, though, to see if it's something more? You with me, my man? Thank you, sir. Yes, sir.
All these rules are basically like identifying quadrilateral from parallelogram.
All of these rules are basically, exactly, they're teaching you how to identify. When you see a quadrilateral, how to recognize straight up if it's just purely a parallelogram. Okay, my man? Thank you, sir. And then number five, if both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. So if this is congruent to that, then it's a parallelogram. And then again, Mr. Morrow, squares have that property. Rhombus have that property. Rectangles have that property. What are you doing to us? No. If I give you a figure and I just give you those markings, or not just me, SAT, ACT, a real life situation, you're out there in the field, that is a parallelogram. Okay? Okay, Mr. Morrow. Then how would I make that a square or a rhombus? Well, I would make this a rhombus very easy. Now it's a rhombus. Because opposite angles are congruent and all sides are congruent. Ah, that's a rhombus. Because a rhombus is a parallelogram, which by definition we already explained that this is a parallelogram because opposite angles are congruent. And it's a rhombus because all sides are congruent. So if all sides are congruent and opposite angles are congruent, that's a rhombus. Why isn't it a square? It's not a square because that's not a 90-degree angle. If that was a 90-degree angle, then that would have been a square. Are you guys seeing where I'm building with this? I know this isn't super simple, but at the same time, Once you start seeing the puzzle pieces, it becomes pretty easy. Does that make sense, guys? Yes, sir. Yes. Thank you. Just about everything is a parallelogram. Exact every quadrilateral, almost, right? Kites are one of the few exceptions. Thank you, my brother. May I continue, boys? All right, brothers. Let's do this. All right, guys. Long proofs, okay? But we got this. Figure ACDF is a parallelogram. Angle AFB is congruent to ECD. I want to prove that FBCE is a parallelogram. Okay, when we get to stuff like this, me personally, I like to highlight what it is that I'm proving. I want to prove that this blue quadrilateral here is a parallelogram. That's what I want to prove. And of course, like always, we're going to start with our givens. ACDF is a parallelogram. Well, if ACDF is a parallelogram, I know by definition that angle A has to be congruent to angle D. Why do we know that? It was one of the five things that we had proved just a few minutes ago that we proved. We said this has to be a parallelogram. It's one of the pure definitions of it. Okay? And you're going to see why I'm going this route. Yes, sir. AF is congruent to CD. Wow. It's exactly the route I thought of. Good job, son. And AF is congruent to DC because definition of a parallelogram. Very good. Because opposite sides of a parallelogram are congruent. That is a pure definition of a parallelogram. Yes, sir, my brother. Correct. You could state that these are parallel, but I'm not being sarcastic. The question here would be then, what benefit would that give you? Okay? So the answer, yes, you could have. It would be one of those things where I wouldn't take points off, but it would be more like I'd put a little so, Okay, how does that help you, in other words? Number 4. I'm sorry. Sorry, I started without answering your question. What's up, buddy? Oh, you were going to say this? Okay, sorry about that, my man. So now angle AFB is congruent to angle ECD because that's given. Okay? So this guy here is congruent to this guy here. Okay? So if you think about it, using the givens, that's why I'm creating two congruent triangles now. Yes, sir. Yes? By which one? You got it, brother. See, you don't need me. Triangle AFB is congruent to triangle DCE because of angle side angle. Fantastic. Yes, sir? It's kind of like a detour. Yes, it's all building. I'm very proud of you. Now what, though, guys? Now that I have it, those two triangles are congruent, now what? Sir. I love it. FB is congruent to EC because of CBCDC. Oh, yeah. Now, I can say that AB is congruent to ED because of CBCDC. So that means that this guy is congruent to this guy. And then this guy is congruent to this guy. Where do you think I'm going from here? AC is congruent to FD because of definition of parallelogram. Right? Come again, my brother? Whoa. Right. Right. And then now, I love it. Well done, son. Now BC is congruent to FE because of subtraction. So now this guy is congruent to this guy. And then I can prove that FBC is congruent, is a parallelogram because if both pairs of opposite sides are congruent, then it is a parallelogram. You could say definition of parallelogram, yes, I will accept that. But the real reason, the real definition that you're using is because both pairs of opposite sides are congruent. I don't get it, Mr. Morrow. Well, look, check it out. Um, we got these two sides are congruent, and these two opposite sides are congruent. So if both pairs of opposite sides are congruent, then it is a parallelogram. Yes, sir. Yeah, we had just stated that. You could put, if you want here, definition of parallelogram. But technically, the real reason is, it is definition of parallelogram, but which definition? Which definition? It's if both pairs of opposite sides are congruent, then it is a parallelogram. Actually, I would really like this, actually, guys, as your final proof. I kind of let you slide on all of these, right? On the final proof, I would like to know what pure definition made this a parallelogram. So you know what? Let's scratch this out. I'll let you slide for all of them except for the end. I think that's fair. At the end, what definition made this a parallelogram? The fact that if both pairs of opposite sides are congruent, then it is a parallelogram. Is that fair? You can use definition of parallelogram all the way throughout until you prove at the end, you're proving that you made a parallelogram. Is that fair? Thank you, brothers. May I continue? Yeah? I don't want to jam anyone up. We're good? Okay. Thank you, gentlemen. Okay. Triangle car is isosceles. So think about what isosceles means. Okay, think about that. With base CR. AC is congruent to BK. Okay. And I think that's wrong. I don't think. I know that's wrong. AC is congruent to B. Oh, no. That's right. I'm a fool. AC is congruent to BK, and angle C is congruent to angle K. Think about where this is going. Think about what figures we've created here. Yes, someone said it, but don't go out loud yet. So number one, of course, triangle car is isosceles with base CR. That's a given. If triangle car is isosceles, then I know that AC is congruent to AR. And I'm nice to you guys. Definition of isosceles triangle. I don't make you say the sides of the legs of a isosceles triangle are congruent. So if that's the case, AC is congruent to BK. That's given. So AC is congruent to BK. That's given. Thank you. You make me very proud, son. AR is congruent to BK then because of transitive property. Very, very, very well done, son. Then I can say that angle C is congruent to angle ARC. Definition of isosceles triangle. So this guy is congruent to this guy. And just in case you were wondering, no, you cannot just say angle R, because there are several angle R's here. There are actually 3 angle R's. There's ARC, there's ARK, and there's CRK. So now I have that angle C is congruent to angle ARC. Then I can say that angle C is congruent to angle K. Why can I say that angle C is congruent to angle K? It's given. It's given. Very good. Okay. Then from there, I can say that angle ARC is congruent to angle K because of transitive. Very good, my brother. Very good, my brother. And then I can say that AR is parallel to BK. Why? Why would AR be parallel to BK? Think of the angles here. Yes. Think of the F. No. Corresponding. Very well done, son. Corresponding angles are congruent, then you have parallel lines. Very nice, man. Very nice. So then I get to my final proof that BARK is a parallelogram. Why? You cannot say definition of parallelogram. Which definition?
Opposite pairs are parallel and congruent.
If one pair of opposite sides are parallel and congruent, then it's a parallelogram. Bam! Great job, kid. Well done, dude. Really. Sweet. Guys, I know it's a long proof, but be honest. It's a pretty easy flow, isn't it? And if you really think about all the proofs we've done, they should be starting to become easy now. They should be getting a little bit easier, though, at least, right? But I know it's a long one, guys, so I'll answer any question you have. I mean, you guys are doing amazing. Great job. May I continue, my brothers?
Sir,
You got it, Papa? Judge, just tell me, bro. Promise? We're good? Okay, okay, thank you. All right, here, quadrilateral quad with angles as shown. That's given. Show that quad is a parallelogram. What? Huh? What do I do here? I don't even get it. What do I got, bro?
put the x squared to the fifth exponent is equal to x to the 10th.
Right.
Or you can prove that 3x the other way around.
Correct. What I'm trying to prove here, which my boy articulated greatly, was he's going back to that first page that we learned today. He's going back to the basic. He said, okay, I have a quadrilateral. I want to prove it's a parallelogram. I was given nothing about the sides, but I'm giving some stuff about the angles. So what he's saying is I have to prove that opposite angles are congruent. Actually, just one pair, right?
Yeah, but you can do it either
But you could do either way. So what happens here, guys, when you raise a power to a power? You multiply them, so that's x to the 10th. And then, or you could distribute, which just becomes 3x cubed minus 15x squared. So either way you look at it, opposite angles are congruent. That's it. It's a parallelogram. You only have to prove one, if I'm not mistaken, from our first slide, right?
Yep.
Just one pair.
So if one was congruent, the other one wasn't?
If one was congruent, the other one has to be, by definition, because they're going to be the two consecutive angles are going to be supplementary. So, thank you, my brother. And last but not least, my brothers, NRTW is a parallelogram. NX is congruent to TS. WV is congruent to PR. And XPSV is a parallelogram is what I want to prove. So I want to prove that this guy right here, XPSV, is a parallelogram. So of course we're going to start with our proof. NRTW is a parallelogram, given. Once we know that's given, we know that angle N is congruent to angle T. Now here I got a little fancy. You could have simply put definition of parallelogram. I will accept that. I'm not going to go opposite of my word right now. NX is congruent to TS. That's a given. So this guy is congruent to this guy. NR is congruent to WT. So NR, which is this, I'll just circle this whole side here, is congruent to WT. That's definition of parallelogram because opposite sides of a parallelogram are congruent. WV is congruent to PR. That's given. So very good. You're going to use subtraction to prove that NP is congruent to VT. So now think about it. Look at this little triangle that I created here. What can I prove about these two red triangles that I just outlined? They're congruent because of side angle side. Very good. So triangle NXP is congruent to triangle TSV, side angle side.
XP is congruent to VS.
Now XP is congruent to VS because of CBCTC.
Uh, Say both pair of opposite sides. When you have to prove that it's also parallel.
Um, yeah, I think we're missing one thing here though. Wait a second. What do we got here? In a similar manner. Oh, okay. No, yeah. Wait, there's still one more thing. That's why. Okay. In the same fashion or in a similar manner, WXB is congruent to triangle RSP, and XV is congruent to PS because steps 1 through 8. If I redid all of these steps, I'm going to prove the same exact thing for these two little triangles. I'm just shortening it up.
You can do that.
Yeah. And now once I prove that, I prove that this guy is congruent to this guy. And now I've proven that both pairs of opposite sides are congruent. So therefore, it is a triangle. It is a parallelogram because both pairs of opposite sides are congruent. So then it is a parallelogram.
Is there another example?
That's it. I think we are perfectly done.
Great lesson.
Very good lesson, guys. Thank you. Awesome questions. Homework is valid. God bless you and have a great day. Thank you. Bye-bye.